Wait, what if I told you that using AI is actually making highly experienced programmers slower? Yeah, 19% slower to be exact. It sounds completely backwards, right? I mean, everywhere you look, software developers are using AI tools more than ever before. But a rigorous new study has just completely flipped the narrative on its head. Welcome to The Explainer. Today, we are going to cut right through the hype. We're tearing down the buzzwords to look at hard, undeniable data from GitHub and Stack Overflow to find out what is actually happening to software engineering right now. Are developers about to be replaced, or are we looking at something else entirely? Let's dive in.
To really understand where we are today, we need to take a quick step back to 2011. That's when venture capitalist Mark Andreessen made his famous, frankly prophetic prediction that, quote, software is eating the world. He envisioned this massive, dramatic technological and economic shift. He saw a future where software companies would just systematically take over huge swaths of the traditional economy. We're talking everything from movies and entertainment to agriculture, all the way up to national defense. And as you know, he hit the nail on the head. He was completely right. Over the last decade and a half, virtually every single company on the planet has essentially been forced to become a software company just to survive. But today, the landscape has fundamentally shifted all over again, and it's bringing us to a brand new, highly urgent crisis of productivity and complexity.
Which leads us directly to the billion-dollar question, the one that's literally dominating every single conversation in the tech industry right now. Is AI eating software engineers? So over the next few minutes, we are going to unpack this. We're going to figure out if the massive, unprecedented rise of generative AI tools actually means the end of traditional programming as we know it, or if it represents an entirely different kind of transformation. We'll look at what AI is actually successfully making cheaper, why writing production-level software still remains incredibly, stubbornly hard, and how engineers can practically predict their own future in this rapidly changing landscape.
Okay, let's start by wrapping our heads around the sheer scale of what is happening right now. According to the 2025 GitHub Octaverse data, generative AI is absolutely not just some fringe experiment anymore. It is the standard. It is baked right into modern development. We are now looking at over 1.1 million public repositories that actively use a large language model SDK. And here's the crazy part. An astonishing 693,867 of those projects were created in just the last 12 months alone. That is a massive 178% year-over-year jump. And the adoption? It happens almost instantly. Get this, 80% of new developers on GitHub are using Copilot in their very first week. Because of this phenomenal, wildfire-like adoption rate, asking, will AI replace engineers is honestly kind of the wrong question. AI is already fundamentally, deeply integrated into how developers work every single day. The real question we need to be asking is, what are they actually using it for?
Well, the 2025 Stack Overflow Developer Survey reveals exactly where AI is providing tangible value today, and the breakdown is super revealing. When developers were asked how they actually use AI, 54.1% said they use it for searching for answers. Another 30.8% said they use it for documenting their code. But here is the kicker. Surprisingly, only 16.9% are using it mostly to actually write code. Think about that for a second. Developers are highly satisfied using AI as an ultra-smart search engine to learn new concepts, or maybe to churn out synthetic data, but they are far, far more hesitant to hand over the keys to actual production code generation. What this shows us is that AI has radically commoditized the search for information and the generation of boilerplate text for sure, but it has absolutely not commoditized the core engineering process itself.
So this brings up a really fascinating point. If AI is supposedly so incredibly helpful, why aren't developers coding at absolute lightning speed? Well, a massive randomized controlled trial conducted by Meta in July 2025 decided to test exactly this on experienced open-source developers. And just to be clear, these were not beginners. These were seasoned developers working on massive, complex repositories with over 1 million lines of code. The researchers randomly assigned complex issues to be solved either with or without AI assistance, and they used state-of-the-art models like Claude 3.5 and 3.7 Sonnet. The result? You might want to brace yourself for this one. When developers used these cutting-edge AI tools, they actually took 19% longer to complete the issues. Just let that sink in for a moment. Using AI made these highly experienced developers significantly slower. And that brings us to a really striking paradox. Right after the study, the researchers asked these exact same developers how much faster they thought the AI had made them. On average, the developers estimated that their workflow was sped up by about 20%.
So look at this disconnect. The empirical reality, proven by the timer, was a 19% slowdown, but their own personal perception was a 20% speed up. Why is there such a massive, glaring delusion here? Well, it's mostly because AI generates lines of code instantly. I mean, it feels incredibly fast and wildly productive to watch an AI agent just spit out 50 lines of code in 2 seconds flat. But as any veteran will tell you, software engineering isn't just about typing characters fast. It's about making absolutely sure those characters do exactly what they are supposed to do within a massive, highly interconnected system. And as it turns out, untangling and debugging these subtle, overly confident errors that an LLM inevitably makes, that often takes far more time than just sitting down and writing the code yourself from scratch.
This whole dynamic introduces a massive, creeping risk for modern development, and it's tied to a really important concept known as technical debt. Ward Cunningham, who was one of the original authors of the Agile Manifesto, defined technical debt as what happens when you take coding shortcuts just to deliver something early. It's exactly like financial debt. Taking on a little bit of debt can speed you up in the short term, sure, but you eventually have to pay interest on it. And in software, that interest is paid in the form of drastically decreased future productivity. Every single minute spent untangling code that isn't quite right counts as interest. So when you have an AI generating code instantly, but you aren't rigorously, meticulously reviewing how it fits into your overall architecture, you aren't just writing code, you are literally printing technical debt. Left unreviewed, these AI-generated shortcuts can easily bring entire engineering organizations to a complete grinding halt under the crushing weight of an unfactored, messy codebase.
So, to truly understand why writing production software is still so unbelievably hard, even with a supercomputer doing the typing, we actually need to bridge the gap between our 2025 AI reality and classic computer science theory. In his legendary, seminal 1986 paper, software engineer Fred Brooks famously wrote, "There is inherently no silver bullet." At the time, he was responding to the desperate cries of project managers who were begging for some magical tool that would make software costs drop as rapidly as computer hardware costs were dropping. But Brooks argued that building software will always be hard, no matter what tools we invent, because of the fundamental, inescapable nature of what software actually is. The absolutely crucial point here is how Brooks broke his theory down into two distinct parts: accidental complexity and essential complexity. Accidental complexity involves all the artificial barriers we put up, things like dealing with awkward programming languages, remembering exactly how to format syntax, or typing out endless repetitive boilerplate. Now, generative AI, it is an absolute miracle cure for accidental complexity. It writes boilerplate beautifully, it remembers syntax perfectly. But then you have essential complexity. This is the actual conceptualization. It's the precise specification and the high-level design of the software construct itself. It's the deep human work of figuring out how all the logic weaves together across a million different lines of code to solve a unique business problem. And AI struggles deeply with essential complexity. So here is the irony. As AI wipes out all the tedious accidental complexity, all that is left for the software engineer to manage is pure, unadulterated essential complexity, which has always been the hardest part of the job anyway. Because developers are suddenly spending way more of their time managing this massive influx of complex AI-generated code, they are actively changing the fundamental tools they use every day to survive it. Let's look back at the 2025 GitHub Octoverse data. It shows a fascinating shift. TypeScript has officially overtaken both Python and JavaScript to become the #1 most used language on GitHub. It grew by over 1 million new contributors in just a single year. That doesn't happen by accident. So why did TypeScript win the crown? Simply put, because future engineers are adapting to their new environment. TypeScript is a strictly typed language, and its meteoric rise perfectly illustrates how developers are actively choosing tools that make agent-assisted coding safer and more reliable. You see, type systems act as strict mathematical contracts that heavily reduce ambiguity. When an AI generates a chunk of code, a strong type system acts like a bouncer. It catches the AI's errors before that bad code ever gets near production. In fact, a 2025 academic study actually found that an overwhelming 94% of LLM-generated compile errors were simply type check failures. By embracing strictly typed systems, developers are essentially building massive, impenetrable guardrails around their AI tools, ensuring that the code their AI assistants write actually conforms to the rigorous rules of their existing system.
This major shift in tooling points directly to what the day-to-day role of a software developer is actually morphing into. We are witnessing a real-time transition from traditional software engineering over to what expert Chip Huan details in her book, AI Engineering, Building Applications with Foundation Models. It's just no longer about memorizing and typing out logic. The job is becoming all about engineering robust, fail-safe systems around these massive pre-trained foundation models. The barrier to entry to make a basic app has totally plummeted. Sure, you can build a weekend project without writing a single line of code now, but taking that prototype and making it a reliable, secure, and scalable product that won't break, that requires an entirely new, highly specialized discipline.
Developers who want to stay ahead of the curve can effectively predict their own future just by mastering this new engineering toolkit. As Chip Huan outlines, the new essential skills are totally different. They involve the rigorous, systematic evaluation of model outputs. Meaning, can you mathematically prove that the AI actually did what you asked it to do? The toolkit also involves designing complex retrieval augmented generation, or RAG systems, to feed models the exact right context they need to be useful. It involves heavily detecting and mitigating AI hallucinations, so your business doesn't make a wildly costly, embarrassing mistake. And it involves relentlessly optimizing these systems for latency, security, and cost efficiency. The daily job is decisively shifting away from writing the code yourself and moving toward orchestrating, evaluating, and managing complex AI systems that generate the code for you. So what does this all mean for us? As AI inevitably writes more and more of the raw code, humans are left to manage the complexity. The data clearly shows us that AI is an incredible, life-changing tool for search, for documentation, and for completely eliminating boilerplate. But that same data also clearly warns us that without strict guardrails, rigid type systems, and highly experienced human oversight, AI can actually slow us down and pile up a mountain of technical debt. The bottom line, software engineering isn't disappearing at all. It is simply transforming into complexity management. The elite engineers of tomorrow aren't going to be defined by how many words per minute they can type, but by how well they can steer, audit, and tame the complex systems doing the typing for them.
Ultimately, despite all the doomsday headlines, the future isn't man versus machine. It's a partnership. It's collaboration. The developers who unlock the real treasure in this industry won't be the ones desperately trying to type faster than a computer. They'll be the ones who master orchestrating the AI to do the heavy lifting for them. So as we fully enter this new era of AI engineering, I want to leave you with one thought. Ask yourself, are you preparing to write code, or are you preparing to manage complexity? Let us know down in the comments exactly how AI has changed your personal workflow this year. Thanks so much for joining us on this explainer, and we will see you next time.